Well, hello. Today we're going to work on simplifying radicals. Our objective today is to simplify radicals involving products, and we'll do quotients in another lesson. So in the solve it that's coming up here, the maximum height of the mirror is a radical expression. A radical expression such as 2 times the square root of 3 or the square root of x plus 3. This is an expression that contains a radical. A radical expression is simplified if the following statements are true about it. So you're trying to get it to these ones. Radicand has no perfect square factors other than 1, so you're kind of looking for those, because those can be factored more. The radicand contains no fractions, so you're trying to deal with those fractions, and no radicals appear in the denominator of a fraction, so we'll deal with that in the next lesson. So when you look at these simplified ones, these are some versions of ones. It's 3 times the square root of 5, that is simplified. 9 times the square root of x, the square root of 2 over 4, those are all indeed simplified. Not simplified is 3 times the square root of 12, because 12 can be factored some more. Square root of x over 2, we have an issue with the fraction in there. And then 5 over the square root of 7. Having the square root in your denominator is also an issue and not simplified. So we'll talk about what to do and how to simplify each one of those when they do show up. Essential understanding, you can simplify radical expressions using multiplication and division properties of square roots. And that shows up in this example where, like square root of 48, it shows up as square root of 16 times square root of 3. 16 is a perfect square, so I can simplify it by turning my square root of 16 into 4, and then I keep my radical. So square root of 48 is equal to 4 times square root of 3, and that is entirely simplified. That's a simplified radical. So we're going to try this out. Okay, we're going to remove the perfect square factors in this one. So square root of 160. I can see that 160 does have a perfect square in there. I can see that it is made up of the square root of 16 times 10. And I can see that 16 is indeed a square root. So square root of 16 times square root of 10. Square root of 16 is 4. And I can leave my 10. So the simplified form of square root of 160 is 4 times square root of 10. I would like you to find the simplified form of square root of 72. Why don't you press pause and give it a try. All right, square root of 72 is made up of 36 times 2. 36 is my perfect square, so I can find the square root of 36, which is 6. My answer is 6 times the square root of 2. Sometimes you can simplify a radical expression that contains variables. A variable with an even exponent is a perfect square. So that's what you're looking for. You're looking for not only perfect squares, but you're looking for exponents with even, you're looking for variables with even exponents, and that is also a perfect square. And we can play that out in a couple of examples here. Like for instance, the square root of the n to the third is equal to square root of n squared times n, and we can pull the n squared out because the square root of n squared is n. That being the case, in this situation, n squared gets factored out to being n, and we're left with n inside there. And we're going to try that out, and this time we do have numbers and variables to interact with. Okay. What is the simplest form of square root of 54 times n to the 7th? Okay, so I'm going to look at this one. I see that 54 is the square root of 9 times 6, 9 being my perfect square. So square root of 9 times square root of 6. So I can see that my 9 is 3, and I can't factor that 6 out, so I have 3 times the square root of 6. If I interact with my variable, which generally I'm going to do with the whole process, but I'm going to break it apart just for this moment. I've got the square root of n to the 7th. Now remember up here, I'm going to be looking at a variable with an even exponent. So I'm going to break this into the pieces to get an even exponent. Like for instance, n to the 6th times n. And what I'm going to do with that n to the 6th is that is equal to n to the 3rd squared times n. That's what that's going to end up being. No, I don't want you to do that one. N to the 6th is equal to n to the 3rd power squared. So I'm taking the square root of n to the 3rd power squared, And so that's why I can take this and factor it out. And so n to the 6th power, the square root of n to the 6th power, can be seen as n to the 3rd. And then what's left in there is an n. So that's why I'm looking for that even term. So I'm going to take and pull these two together. I have 3 times square root of 6 and n squared times n, and I end up with 3 n to the 3rd times 6 n. And really, if I want to, I can do all of these together. I took the numbers and I took the variables and did them separately, but as you get working on these a little bit more, you're going to find out that you can do these together, interchangeably with each other. All right, I want you to try the got it. Why don't you press pause and you give it a try with this one. Pause. All right, let's take a look at all the pieces here. What I did is I took my 80 and broke it into 4 times 20, but I also noticed my 20 can be broken up into 4 times 5. Again, looking for those perfect squares of this being 4. So that's why I can pull the 4 and the 4 out as my 2 and my 2. I took my variable of m to the 9th and I looked for an even exponent, so that's why I have m to the 8th times m. M to the 8th becomes m to the 4th out here because m to the 4th squared. I square root that. I end up with m to the 4th. So really, I'm going to take my exponent of an even number and cut it in half. That's really what I'm doing here. So I combined my like terms. I factored out the 2 4s, get my 2's, and kind of combined all my like terms and brought it together, and I end up with negative 4m to the 5th times the square root of 5m. You can also use the multiplication property of square roots to write this. So I can pull some things together, like square root of a times the square root of b equals the square root of ab. So I can bring some things together here. I can multiply all these together. So I can multiply my 2 times 3 times 7t times 14t squared. I can simplify all of these and I end up with 6 times the square root of 98t to the 3rd. And I can see that's an odd exponent, so I'm going to have to deal with that in a bit. So that's going to be 6 times my 98 can become 49. And my t squared, I'm going to break it up into t to the 2nd power and a second t. So here's my 2 pieces. So I'm going to take my 98, I'm going to break it up to 49 times 2, which gave me a perfect square. I'm going to take my t to the 3rd, I'm going to break it up into t squared times t. And this allows me to do some factoring here. So 49t squared factors out to 7t times 6 times the square root of 2t. That's what's left in there. I take 7t times 6 and I end up with 42t times the square root of 2t. And that is my simplified radical. I think you get to try it. Oh yeah, you get to try it. I've got a few from here. Why don't you go ahead and press pause and work through each one and see how you did. I'm going to work all of them. So press pause, you work through all of them, and then play again and let's see how we all did. Good luck. Do your best. I just want to take a look at the first one real quick. You can do this a couple different ways. This first on the left side of the blue line here, I multiplied everything together and factored out 108. And I got 9 times 4 times 3, looking for the 9 and the 4, the perfect squares, and thus factoring them out. On the right side, I noticed that the 18 could be factored out. I factored a 9 out, and that's why square root of 18, I found 3 times the square root of 2. I did 3 times 3, and I did square root of 6 times square root of 2, and that's why I'm working with the 12, and I factored that out. Looking for a perfect square, factored out the 2, multiplied, and I got the same answer. So there's a few different ways you can do it. You just kind of have to decide what's easier and what's not. I'm going to press pause again and work on the other one. All right, here's my last couple here. For B, I went and just multiplied everything together and then factor out of my 18, looking for the perfect square of 9. and then 2. I was able to factor out that 9. For C, I again multiplied everything together. I got my 21 times the square root of 100 and x to the 6th. My x to the 6th being an even term, so I was able to factor out that to being x to the 3rd. When the square root of 100 is 10, multiplied all that together to get 210 x to the 3rd power. All right. Speaking of power, I'm going to go and continue to work on my invention of the solar-powered pencil. Oh yeah, people are going to love that.